So today what I'm going to do, as one of you guys requested, I'm going to just do one of the examples that we had on the sample test, but I'm going to do that question in terms of like reviewing all the KVL, KCL, and our conventions. So I'm going to try to like review like the materials that we have through that example. Okay? But what's the question? So the question is, example, the question is telling us if power supplied by 2 amps current source is 40 watts, find power of 5-volt source. And the circuit is this. I have a 5 ohms resistance. I have a 2 amps current source. Then I have a 10 ohms resistor, a 5 ohms resistance, another 5 ohms resistance, some source with value Vs, a 5 volts source, and a 5 ohms resistance. Right? The question is, what is power for this element? Right? A couple of quick things about this problem. Right? If you look at this problem, this Vs is not given to us. So we got to somehow compute that Vs to be able to like find whatever else we want to find in the circuit. And as soon as we're missing information, some other information should be given to us to account for what's missing. The extra information that was given to me is that power supplied by 2 amps source is 40 watts. That is the extra information, right? So let's quickly go over like power on our convention. So a reminder, let's just say I have some element. This element can be anything, can be like, you know, a current source, voltage source, a resistor, any element, right? I have some current going through it this way. And let's just say voltage across it is V, right? We know power for this element is always VI, right? But this power could be positive or negative. It is positive if this current, which is the positive direction of the current, hits the positive sign of the voltage here. What it means is that voltage across this element here is positive, current through it is positive, therefore VI is positive. And if the power is positive, we say the power is being absorbed, right? But if positive direction of current hits the negative sign of this V, what it means is that if I look at this formula VI, V across this element is negative. Therefore, VI is negative. So if current hits the negative sign, power is negative, which means the power is being supplied, right? So if power is positive, the power is being absorbed. If power is negative, power is being supplied. Right? Is this convention clear to everybody? Is that clear why, basically like where this is positive and where this is negative? You're definitely going to have one question on power. Again, I'm telling you what's going to be on the exam. So if there is anything we don't understand about this, let's clear it up. Is that clear? Yes. No, both voltage and current. Because if this current is the positive direction, and if I flip the sign over here for the V, then this current hits the negative sign, that becomes like negative, right? But if this current is the negative sign, and I flip the direction, again, negative and negative, that would be positive. Yes. So let's see what this question is telling us. The question is telling us power is supplied by 2 amps current source is 40. What does that dictate to us? It basically dictates to us the direction that I have for the voltage. So what is the direction? Is this positive or negative? Is this end positive or negative? It should be negative, right? Because it's supplied. So what it means is that whatever direction that I have for the current should hit the negative sign first, right? So this direction over here is indeed the direction that's being dictated to me by the fact that the question is telling me power supplied by this element is 40 watts, right? Is that clear how I got that direction? So that is the direction I cannot change. That is the direction that's dictated to me, and I have to stick to it. Whatever other direction I can choose, I need to have, basically, for that 5 ohms resistor, 10 ohms resistor, those are up to me. I can decide on those. But for this independent current source, it is dictated to me that is the polarity for this source. Is that clear? Is that obvious to everybody why this is negative positive? So let's try to solve the problem then. Now I know the direction is negative positive. I know power is always being calculated by VI, right? I know current through this element, so I know exactly what this V is. Do I? I do, right? So I know V equals P over I. I know P is 40 watts. I through this is 2. Therefore, V is 20 volts. Right? We know that. Let's call this voltage over here V prime, which is voltage across this phi. I'm claiming I know exactly what V prime is. Do we? What is V prime in general? It is the value of the resistor, which is 5, times current through it. What is current through it? 2. Why? Because remember, these 2 elements are in series. And if 2 elements are in series, current through one must be the exact same as current through the other one. But I know current through this one is 2, therefore current through this must be 2 as well. And I know the direction of the current is from left to right. Right? So if I want to write V prime, I hit the positive sign first. So V prime is positive. So V prime is 5 times current through it, which is 5 times 2, which is 10 volts. Right? I'm going to call current through here I naught. What is I naught? That's 2 milliamps, right? If I look at like the top loop, the current is like 2 milliamps, right? So another thing we know is that I naught is 2 amps. Right? What else do I know in this circuit? Let me call voltage across this 10 ohms V double prime. This is positive, this is negative, and we call it V double prime. How do I choose that direction, that polarity? Completely up to me. If I want to just flip the sign, go for it. But as soon as you choose that direction, you got to stick to it. Over here, I chose that direction. Right? What I'm claiming is that I know exactly what this V double prime is. What is it? Well, I can write a KVL here. Right? On top of that, I know like this 10 ohms is in parallel with these two. Right? So voltage across this plus voltage across this must be voltage across this. But let's just write a KVL. Right? So KVL for top loop tells me, let's just start here. V prime minus V plus V double prime must be 0. Right? That's a KVL. We can write KVL in any closed loop. That's the loop that we chose. I know V prime, I know V, I can compute V double prime. Therefore, V double prime is V minus V prime. I know V is 20, V double prime is 10, so that is 20 minus 10. V double prime is 10 volts. Right? So I know voltage across this guy. As soon as I know voltage across it, I know exactly what current through it is. Do we? Of course. So let me call this current over here I1. What is I1? Again, I1 is hitting like the positive sign. So it is V double prime divided by the value of the resistance. Right? That's Ohm's law. Therefore, I1 is V double prime divided by 10 ohms. V double prime is 10 divided by 10, so it's 1 amps. Right? Right? Look at the circuit. Do you agree voltage across this 5 ohms resistance is 5 volts? Do you agree with that? Yeah, because they're in parallel. If I have two elements that are sharing the exact same head and tail, it means voltage across one must be the same as voltage across the other one. Right? So voltage across this 5 ohms resistance must be this 5 volts. How about this 5 ohms on the left? What is voltage across this 5 ohms? Is that 5? No, because this 5 ohms is not in parallel with this. How about voltage across this to be Vs? Is that correct? Is that Vs? Is that? Absolutely not, because I have this 5 ohms resistance on the top, right? Which tells me I have to have like some voltage drop, right? What I do know is that if I know current through this 5 ohms, basically if I know current through this 5 ohms right here, if I know current through this, I know voltage across these two, and I can compute Vs, right? But I do know voltage across this 5 ohms is not Vs because I have the drop across this 5 ohms. Nonetheless, I know this 5 ohms resistance is in parallel with this 5 volts. Therefore, I know voltage across it. Right? Let's call voltage across this what do we call it? Let's just call it like V5. Right? Again, I know V5 is 5. If you cannot see it this way, you can always write a KVL. V5 minus 5 must be 0, therefore V5 is 5. Right? So we know V5 is 5 volts. As soon as I know voltage across this 5 ohms resistance, do you agree I know this current? Let's just call it I2. Do you agree I know that? Right? I have Ohm's law. So I2 is V5 divided by 5, which is 5 volts divided by 5, which is 1 amps. Right? Here's the thing. If I write a KCL at this point, I'm done. Right? Because I can find current through this branch. I know this current, I know this current, and I know this current. Right? I'm done. I can find VI. Right? I'm not going to do that. I'm going to find VS as well, because this is a practice. Right? On the exam, you're done here. Right? On the exam, if that was the question, you just need to write a KCL at this point. Let's just call it A. And let's just try to find this current. Let's just call it I3. Right? So writing a KCL at A, what does it tell me? It tells me whatever current that goes in must be the same as the current that's going out. Right? In this case, what do we have? I have I3 going in. The rest are going out. Right? So KCL at A tells me I3 equals I2. I1 is going in too. Plus I1. That is I2 plus I0. Right? This is the current that's going in. This is the current that's going out. I know everything here, right? I can find I3. So here, I3 is I2 plus I0 minus I1. I know I2, that's 1. I know I0, which is 2. And I know I1, which is 1. So that is 2 amps. Right? And if I compute P for this P at 5 volts, that is VI. Is it positive or negative? Positive or negative? Negative, right? Because voltage across this source is -5, right? We're hitting the negative sign first, right? If you look at the direction of the current, the direction of the current is upwards. So it hits the negative sign first. So for the positive current, we hit the negative sign, right? Therefore, our power is negative, right? So my power here is VI, which is 5 times 2. This is 10 watts, but it's supplied. That's like another way of like saying it is negative, right? Or I can just like write like P equals minus 10 watts, right? Same thing. So if it was the question on the exam, you were done. You didn't even have to compute VS, right? We're done. We wanted power, we got the power. Well, let's actually find VS, see like what it is. How do we do this? How do we do this? Do you agree I can write a KVL and this loop? can write a KVL in any loop I want, but that's the KVL I want. And let's call voltage across this V prime 5, right? So what does KVL tell me? The KVL tells me I have -5 plus negative V double prime plus V prime 5, that is 0, right? Do you agree with this? Well, we hit the negative sign, so I have a negative here. I hit the positive sign, I have positive, and this is negative, so I have this. Do you agree with that, KVL? Yes? Well, look, I know V double prime. We already computed it. I know V double prime is 10 volts, right? You see it? I can plug it in here. So I have -5 minus 10 plus V prime 5 equals 0. Therefore, V prime 5 is 15 volts. So what I do know is that this voltage over here is 15 volts. As soon as I know voltage across it, I know current through it. Let's call this current over here I4. What is I4? Voltage across it divided by its value, right? So due to this, I4 is equal V prime 5 divided by 5, which is 15 divided by 5, which is 3 amps. Right? Right? Very simple. I'm going to call this point, this node over here, node B. Do you agree if I write a KCL at node B, I can find this current, which is I5? Right? Can do that. What does KCL tell me? It tells me whatever current that's going in must be the same as the current that's going out. So KCL at node B. I have this I naught going in. What else is going in? Nothing, right? Everything else is going out. So that equals to I1 plus I4 plus I5. Therefore, I can compute I5. I know I5 is I naught minus I1 minus I4. I computed it I naught. I naught is 2. I1 is 1. I4, we just computed it. It's 3. So that tells me that is negative 2 amp. What does that tell me? What does that tell me that like I5 is negative 2? It just tells me if I wanted to get the positive direction for the current, that should be the reverse of this direction, right? Because it's negative. So if I make the direction backwards, then that would be 2. That's all it tells me, right? What I'm claiming is that I'm done. I can find Vs, right? Why? Because I already know V prime 5. I can compute voltage across this because I know current through it. And I know if I write a KVL for this little loop over here, that should add up to 0, right? So I can compute Vs. So let's write a KVL here. So KVL. What does it tell me? Let's start from here. I have negative V prime 5 plus voltage across this. Voltage across this is 5 times current through it. What is current through it? That's I5. Right? Plus Vs, that must be 0. Right? What is V prime 5? We already computed it. That's 15. So I have negative 15 plus 5 times I5. What is I5? Negative 2. Right? Plus Vs, that must be 0. What is Vs? That's 25 volts. Right? Right? Is that clear how we approach this problem? Yeah? Again, keep that in mind. You can write like nodal analysis. You can do like mesh analysis, right? But given what this problem was asking you, you could just solve this problem by writing 4 equations, right? Basically like 3 KVLs and like 1 KCL. All you needed to do was to find this I3, right? But if you did like nodal analysis, for example, you have to write a KCL at A, you have to write a KCL at B, but since you don't know the value of Vs, you have to compute that as well. So you have to like do one more step. Same thing with like mesh analysis. You can do mesh analysis, but since you don't know like this Vs, you're incorporating that extra information that you have to find that Vs. So it makes it a little like more difficult. So it's easier to only do like a bunch of like KVLs and KCLs, right? Nonetheless, you can write them. You can write like, you know, all the equations for nodal analysis. You can write all the equations for like mesh analysis, and you still should be getting like the exact same answer. So if you have all the time in the world, by all means, do all 3 of them, right? But since it's midterm and you only have like limited time, this would be like the best approach, right? But if it doesn't come to you, you can still do like nodal analysis, right? And mesh analysis should be your last resort. Why? Because if you look at this circuit, you have 4 loops. And if you compare it to nodal analysis, you only have like 2 nodes. So obviously, like having 2 equations is like much easier to deal with rather than like having like 4 equations. Therefore, mesh analysis should be your last resort, right? Does that make sense what's going on? Yes? So let me quickly talk about something which I think is very, very important. Let me quickly talk about like connections, right? And when I'm talking about a connection, I'm not just talking about like connections like, you know, between like 2 resistors or like 10 resistors. No, I'm talking about connections in general, right? If you have like a resistor and like a current source, for example, like what we had in this example, right? So let's quickly define what it means. The first one is the series connection. Remember how we define like series connection? First of all, they got to be back to back. And whatever current that's going through one of them should go through the other one, right? And if these 2 elements are like resistors, I can combine them into like one resistor, right? And I know the current through that equivalent is also the same as current through each resistor. But in general, if I have like any element, like what we had in this example, if you look at it, these two elements are in series. One of them is resistor, the other one is current source. But since these are in series, current through this 5 ohms must be the same as current through this 2 amps. And since I know current through this is like 2, current through this one must be 2 as well. So series connection is when elements are back to back and current through one element is the exact same as current through other element. Right? So if there is a leakage in the middle, these two elements are no longer in series. Right? So if I have something like this, right? Element 1 and element 2 are not in series because there is some current leakage over here. So this is not series. Second is the parallel connection. We call two elements parallel. Again, doesn't have to be like resistor. If they share the exact same head, an exact same tail, and voltage across each element is the same. Exactly the same as like what we had in this example. If you look at this 5 ohms, that's in parallel with this element because they share the exact same head and tail. And voltage across this must be the same as voltage across this. Right? If these two elements are resistors, we learned how to combine them into like one resistor, right? And if I look at the voltage across the equivalent, that is also the same as voltage across each element. Right? Remember that? That was a definition of equivalence. Right? So parallel connection, when elements share the exact same head and exact same tail, and voltage across each element is the same. Right? Does that make sense? So I can use this fact and assume like those elements are basically resistors, right? And simplify down the circuit to like one simple resistor. And we call that like equivalent resistor for that entire circuit, right? But it's not always easy to like pin down like the relationships. It's not always easy to say, oh yeah, these two are in series, these two are like in parallel. It's not always easy. The idea behind it is that if the circuit is like very complicated and you do not know how they're connected, let's just name the nodes. And as soon as you name the nodes, you know exactly what goes between what nodes, and you know exactly like what's back to back and what's not back to back, what's in parallel, what's not in parallel. So the trick to it is always name the nodes. So let's do one example to see like how we can actually do this. This was one of the homework problems. This was problem 2.66. So I have this somewhat scary looking circuit. And the question is, what is R equivalent? First of all, to find R equivalent, I have to start from the solid part of the circuit, the part that I know exactly what's going on. If I look at this portion of the circuit, I don't know exactly what's going on between these two terminals. I don't know if they're like, open circuit, they're like, short circuit. We don't know what's going on there, right? We just know we want to find the equivalent resistance for this black box that we have around those two terminals. So that's not the very solid part of the circuit. The solid part of the circuit is whatever is going around this R equivalent, right? So how do we do this? Like I said, we're going to name the nodes. Do you agree this is a node? This is indeed a node. How about this one? Is it different than A? No. How about this one? Is it any different than A? No. How about here? Is it any different than A? No, it's connected by a wire. How about over here? Nope, still an A. How about here? Still an A. How about here? Still an A. How about here? Still an A. What happened? I have a bunch of resistors that go between A and A. What it means is that all these resistors are in parallel with a wire. Look, A and A, it's a wire. If I have any resistor in parallel with wire, what is the equivalent? To 0. So entire thing here, this goes away because it circles back to A. Right? So the entire thing that goes between A and A, that goes away. How about this node? Is this any different than A? It indeed is, because there's an element in there. How about this node? Is it different than A or B? It is. So we call it a C. What is this node? Still C. How about this? Still C. So this giant, scary-looking circuit only has 3 nodes. So let's see how we can actually have like these elements between these 3 nodes. So let's just call this A. Let's call this B. Let's call this C. Let's see what goes between A and B. Look at the circuit. I have this 12 that goes between A and B. So I'll write it. What else goes between A and B? This terminal, right? So I'll basically write it as here. I need to find this R equivalent. Do I have anything else that goes between A and B? Nothing. What goes between A and C? Well, I have this 12. I have this 12. Do I have anything else? We're done. What goes between B and C? That's only this resistor. Look what happened. This circuit, which we had no idea how the connections were, translated into like this simple circuit that we know exactly like how the relationships are. What is the relationship between these two? They're in parallel because they share the exact same head and exact same tail. So this is parallel. So I have 12 in parallel with 12, which is a 6. And remember, if I have 2 things in parallel, if I replace that by its equivalent, it still goes between those 2 nodes, right? That's a definition of parallel. So I know the 6 still goes between A and C. If that's the case, what is the relationship between this 6 and this 12? They're in series, right? Right? So let me redraw the circuit. I have A, I have B. Again, these two things were in series. If I combine them, still go between like the same nodes, so it still go between A and B. So I have this 18. I have this terminal, then I need to find our equivalent, and I have this 12 up here. What is my equivalent? Aren't these two in parallel? They share the exact same head and tail. Therefore, my R equivalent is 12 in parallel with 18, which is 12 times 18 divided by 12 plus 18, which is 30, whatever that number is. See how easy like the circuit became as soon as I named the nodes? I realized what was in parallel with a wire because I circled back to the exact same node. I realized the resistors that were in parallel, the resistors that were in like series, and I could simplify them down. One thing that's very, very important, if you look at this 12 and this 12, they're not in series, right? Why? Because there's a current leakage over here. So whatever current I have through this 12 is not completely flowing through this 12. Some of them is going to flow through here. Therefore, they're not in series. These two, however, they're in parallel because they have exact same head and tail. Right? Does that make sense? So whenever you're given a circuit that's a little less complicated, the best way to find the equivalent is to name the nodes. And as soon as you name the nodes, you know exactly what goes between what. Right? Any question? Any question? Yes. Yes, you're going to get like delta y on the exam. Well, you may. Yes. Yes. But again, like delta y is like very simple, right? I highly encourage you guys write down the formula on your cheat sheet. Okay? There is a possibility that you may get a question on delta y, right? But if you get a delta y question, that's very, very simple because you just need to like convert it to from delta to y or like y to delta, most likely delta to y, and then the rest is going to be like very easy, right? Pretty much like the examples that we did in class. But this time, like the resistors might not be like the same value. It doesn't really matter, right? Because we know the formula. So have that written down on your cheat sheet. Yes. Oh, you'll see. Yeah, you'll see. It's pretty much just like the exam that you take in class, right? And again, what's very important is that whatever you're allowed to use for the in-person exam, you're allowed to use it for the take-home class exam. You're allowed to have like a cheat sheet, your calculators, and your stationaries, right? Pen, pencil, whatever you need, right? Same thing applies to your take-home. You are not, absolutely not allowed to use AI, any AI, okay? Your TAs, your friends, your tutors, me, other professors. The exam is an individual exam, just like what we do in an in-person class exam, okay? One more thing that's very important. Again, I've said that many, many times. I mostly care about the way you think about the problem. Obviously, I want to see like the final answer, but if you show me all the steps and I realize that you know how to tackle the problem, I'll give you most of the credit, right? So it is mostly for me to see if you know how to approach a circuit rather than just giving me like the final answer. Again, I'll have to mark you off if you don't give me like final answer, but it's not going to be a lot. I'll give you like 95% of like the credit if you show me all basically your work. because the rest is just like giving it to a calculator, right? It doesn't like show me anything. And worst comes to worst, you get the wrong answer. It means like you're not good at like linear algebra. It's got nothing to do with the circuit, right? So for me to see like those equations written correctly and understanding the signs, right? That's the most important part. So I'll give you like most credit if you show me you understood the circuit. Okay? So don't be so hung up on like the final answer. Just, again, it's important to give me like the final answer, but the way you think about the problem is more important to me than the final answer. And as I mentioned, the exam is out of 115 points. You only need to answer 100 points. So 15 points extra credit. All right? I'm sure you guys will do great. Just a study, and I'll see you guys Friday.